All right, picture this. What if the universe isn't just vast and beautiful, but also quietly, stubbornly littered with things that, by all rights, shouldn't even exist? I'm not talking about little cosmic quirks here. I mean giant, screaming violations of everything we thought we knew about physics, about space, about, well, everything. Today, we're going to dive headfirst into 5 of these mind-bending puzzles. No filler, no fluff, just the raw, jaw-dropping observations that have entire teams at NASA, ESA, and pretty much every major university on Earth scratching their heads right now. Seriously, the data is in, and it's telling us things that make our current textbooks look like ancient history. Stick around, because by the time we hit number 1, you'll see why the conversation about alien tech might just be shifting from wild conspiracy theories to legitimate, peer-reviewed scientific headaches. Oumuamua, the interstellar cigar that refuses to behave. Let's rewind to October 2017. A team at the Pan-STARRS telescope in Hawaii is just doing their thing, scanning the night sky when they spot a tiny streak of light. Nothing unusual, right? Space is full of streaks. But this one was different. This one was moving way too fast on a trajectory that immediately screamed, "Hey, I'm not from around here." Its speed, a blistering 196,000 miles per hour, and it was still picking up momentum. Further calculations confirmed it. This object wasn't gravitationally bound to our sun. It had come from interstellar space, passed through our solar system, and was now on its way out, never to return. This was the first interstellar object ever detected, and we named it Oumuamua, which is Hawaiian for a messenger from afar. Now, what was it? That's where things get really weird. Initial observations suggested a highly elongated shape, something like a cosmic cigar, perhaps 10 times longer than it was wide. Imagine a skyscraper tumbling through space, or maybe a pancake, depending on which modeling team you asked. It was estimated to be up to a kilometer long, but only about 167 meters wide, incredibly thin. Conventional wisdom tells us that sunlight should exert a tiny, gentle push on such an object, much like a hairdryer might nudge a dust bunny across the floor. So, as Oumuamua rounded the sun, scientists expected this slight push. Instead, it sped up. Not by much, mind you, about 0.3 millimeters per second every single second. Sounds tiny, right? But in the vacuum of space, with no other obvious forces at play, it was a gigantic anomaly. What could give it that extra kick? Usually, when a comet speeds up like that, it's because ice on its surface is vaporizing, creating jets of gas that act like tiny thrusters. We'd see a tail of water or carbon monoxide, or at least a wisp of dust. But with Oumuamua, nothing. Absolutely no evidence of outgassing. The force was undeniably there, pushing it along, but its source was completely invisible. We gave it the polite scientific label, non-gravitational acceleration, which, let's be honest, is just scientists speak for we have zero clue what's going on here. Trying to trace its path backward was another headache. Simulations suggested it might have originated from a patch of sky in the direction of the star Vega, about 25 light years away. But then other simulations showed that any home star capable of flinging something with this much energy would have to be far older than Vega, which itself is pretty young. So we don't know where it started, we don't know what it's made of, and we definitely don't know why it keeps speeding up without any visible propulsion. This is where things got really interesting. Harvard astrophysicist Avi Loeb, among others, published a paper suggesting that the only way to explain Oumuamua's observed acceleration without outgassing was if it were incredibly thin and light, like a solar sail, a piece of technology designed to be propelled by sunlight. He even floated the idea that it could be alien technology. Now, before you roll your eyes, understand this. His paper is still cited, and crucially, it has not been disproven. Natural explanations have been proposed, ranging from a fragment of an exoplanet, an exopluto made of frozen nitrogen, to a hydrogen iceberg. But every single one of these models requires the object to be so impossibly thin or so porous that we've never seen anything remotely like it in nature. We literally have no known natural analog for what Oumuamua would have to be to fit the data. The sad truth is, we will never photograph it again. It's too far away, too faint. All we have is the data trail it left behind, and that trail says one thing loud and clear. Objects can absolutely break Newton's cozy rules the moment they arrive from outside our solar system. It's a cosmic riddle wrapped in a mystery, and it's just the beginning. Tabby star, the 22% drop that planets cannot do. Now let's jet 1,500 light years away into the constellation Cygnus. Here sits a star named KIC 8462852, but you probably know it better as Tabby star, named after its discoverer. Tabitha was watching it as part of the Kepler survey, a mission designed to find exoplanets by looking for tiny periodic dips in a star's brightness as planets pass in front of it. A Jupiter-sized planet, for instance, might cause a dip of about 1%. That's a small, predictable flicker. But Tabby star? Oh, Tabby star did not get the memo about being predictable. During the 2011 Kepler survey, this star started dimming, not by 1%, but by up to a staggering 22%. Imagine your normal porch light suddenly dimming to a mere fifth of its brightness, then hours or days later, popping back to full power. And it wasn't just one dip. It was a series of completely irregular, non-periodic, chaotic dips. There was no consistent orbit, no repeating pattern, just chaos. This was unlike anything ever seen before. Follow-up observations with ground telescopes revealed an even deeper mystery. The star had also faded by a full 10% across the entire 4 years Kepler was watching it. Think about that for a second. For a star to dim by 10% over such a short timescale, you need something absolutely monumental. We're talking about a swarm of 100,000 comets, each one the size of your hometown, all passing in front of the star at once. And comets, bless their icy hearts, simply do not organize flash mobs. They don't coordinate their movements to create such massive sustained dimming. If it were comets or even just a massive cloud of dust, infrared telescopes like Spitzer should have seen a telltale glow from the warm dust absorbing the starlight. But Spitzer saw nothing. No warm dust. This effectively collapsed the comet swarm and dust cloud ideas. They just didn't fit the data. So what's left? Well, the next runner-up, the one that immediately captured the public imagination, was the idea of alien megastructures, perhaps a Dyson sphere or parts of one under a partial construction around the star. And here's the kicker. This thought experiment survives because we cannot falsify it yet. While it's certainly an extraordinary claim requiring extraordinary evidence, the natural explanations have been so thoroughly debunked or found wanting that it remains a possibility in some corner of the scientific discussion. Meanwhile, new data from 2023 shows that the long-term dimming is still happening. Whatever is blocking the light is either getting more efficient at it, or the star itself is genuinely fading, something stars of this type should absolutely not be doing on human timescales. They're supposed to be stable for billions of years. Astronomers are now leaning toward a hypothetical ring of cold, dark dust orbiting the star at a distance similar to where our own Kuiper belt sits. But even this model struggles. It needs to introduce so many free parameters, essentially tweaking variables to make the model fit the observations, that it starts to feel suspiciously engineered, like forcing a square peg into a round hole. No single elegant model perfectly reproduces the exact light curve without bending the rules a little too much. So we're still left with a star that acts like someone is testing a dimmer switch in slow motion, and we have no idea who's holding the remote. It's a cosmic mystery that continues to defy all our best explanations. Fast radio bursts, millisecond screens from galaxies we can't even see. Let's jump forward to 2007. A team is sifting through old radio astronomy archives, specifically data from the Parkes telescope in Australia. And then,
bam! They stumble upon a signal so incredibly bright, it actually saturated the detectors. It was just 5 milliseconds long. Blink and you'd miss it. But in that tiny fraction of a second, it unleashed as much radio energy as our sun produces in 80 years. That's equivalent to 500 million suns screaming at once. The pulse seemed to come from the direction of the Small Magellanic Cloud, a dwarf galaxy orbiting our Milky Way, but no star or galaxy sat precisely on that line. What on Earth, or off Earth, was that? This was the first fast radio burst, or FRB, ever detected. Since then, we've logged hundreds, even thousands of these events. They're characterized by their incredibly short duration, their immense brightness, and something called dispersion measure, which tells us how much ionized gas the radio wave has traveled through. This dispersion measure consistently points to an extragalactic origin. These bursts are coming from truly colossal distances, far beyond our Milky Way. The kicker for a long time, most of them were one-off events. Imagine hearing a single deafening gunshot in a crowded stadium. You search the security footage, but there's no muzzle flash, no crowd reaction, no shell casing, just the inexplicable bang. This made figuring out their source incredibly difficult. If they didn't repeat, how could you pinpoint them? Then in 2020, the Canadian Hydrogen Intensity Mapping Experiment Telescope, or CHIME, made a breakthrough. It caught FRB 180916, a burst that repeats. But not just randomly repeats, it repeats with clockwork precision every 16.35 days. Think about that. Whatever cosmic engine powers this burst is keeping a schedule across 500 million light years. The host galaxy for this particular FRB was identified as a star-forming region 500 million light years away. So what could possibly create such an immense, short, and sometimes repeating burst of energy? The leading suspect is a magnetar. These are incredibly dense neutron stars with magnetic fields so mind-bogglingly strong they could warp atoms. They are, in essence, cosmic dynamos on steroids. The idea is that starquakes on the magnetar's surface or instabilities in its magnetic field could trigger these powerful radio emissions. We even have magnetars in our own galaxy, and they do occasionally burp out radio waves, but nothing with the sheer, blinding energy of an FRB. The problem is, even if a magnetar is the source, it doesn't fully explain everything. For the radio waves to be so bright and to travel such vast distances, something must be focusing them into an incredibly tight, laser-like beam. Perhaps a dense plasma lens, a kind of cosmic magnifying glass, could do the trick. But for such a lens to exist and survive the cataclysmic explosion that created the magnetar in the first place seems problematic, to say the least. Even wilder is the dispersion measure. For some FRBs, it indicates they've traveled through so much ionized gas that they must have originated from half the universe away. That means the event happened when the cosmos was only about 5 billion years old, a time when the universe was much younger and denser. Yet the energy of these bursts still punches through billions of light years of cosmic noise to reach our telescopes. If you could convert the energy of an FRB into audible sound, it would be like a cosmic snare drum, a single, thunderous clap that could be heard over the 13 billion-year-old crowd noise of the entire universe. We hear the drum, we feel the shockwave, but we still don't know who the drummer is or what kind of drum they're playing. It's a truly baffling signal from the deep past of the cosmos. Odd radio circles, perfect rings bigger than galaxies. Imagine mapping the night sky, not with your eyes, but with radio waves. That's exactly what radio astronomers were doing in 2019, and they stumbled upon something completely new, completely unexpected, and utterly bizarre. 4 perfect circles. These weren't nebulas or galaxies or anything they'd ever seen. Each circle was roughly the width of a full moon in the sky, yet they were entirely invisible to optical telescopes. No stars, no infrared glow, just a crisp, defined radio rim. They called them odd radio circles, or orcs. The largest of these orcs is nearly 1 million light-years across. That's 10 Milky Ways laid side by side. So what could create such an enormous, perfectly circular structure visible only in radio waves? The initial guesses were naturally things we already know about. Could they be expandable soap bubbles in space, like the remains of a powerful explosion? Well, spherical shock waves should fade from the center outwards, getting dimmer as they expand. But orcs are just edges. They're hollow. It's like someone traced a perfect halo and then forgot to color it in. What about supernova remnants? X-ray telescopes should see hot gas from such an event, but they saw no hot gas, ruling out the usual supernova story. They're far too big to be planetary nebulae, which are the shells of gas shed by dying stars. They're too symmetrical and isolated to be the results of chaotic galaxy collisions, and they're too precisely circular for the kind of cluster-wide shocks we sometimes see. One intriguing idea links an orc to a central galaxy that is actively forming stars, hinting that the ring could be the ghost of an ancient, powerful burst of energy, perhaps from a supermassive black hole that traveled outwards for 1 billion years. But for that to happen, you'd need an energy budget comparable to 100,000 supernovae detonating at once in that galaxy's core. Yet we see no evidence of such stellar fireworks or a hyperactive black hole that could produce that kind of power. The central galaxy just doesn't seem energetic enough to be the source of such a colossal ring. Another and even more exotic idea is that these rings are Einstein rings. These occur when radio waves from a distant background source are bent and magnified by the gravity of an unseen, massive object in the foreground, creating a perfect circle of light. The problem with this hypothesis is that the background source needed to create such a perfect radio circle would have to be an incredibly coherent radio lobe, far bigger and more powerful than anything we've ever cataloged. And the foreground lens would need to be precisely aligned and incredibly massive. Until new, more powerful radio telescopes like Meerkat, which discovered them, and the upcoming Square Kilometer Array, SKA, get more coverage and gather more data, orcs remain perfect circles drawn by an invisible hand. They are a genuinely new class of astronomical objects, challenging our understanding of cosmic explosions, large-scale structures, and the very physics of the universe. They are a stark reminder that, even with all our advanced technology, the cosmos still holds fundamental surprises just waiting to be discovered.
The Great Attractor, a hidden mass tugging us at 2 million kilometers per hour. Okay, let's talk cosmic speedometers. Our galaxy, the Milky Way, isn't just sitting still. It's cruising through space at a mind-boggling 630 kilometers per second relative to the cosmic microwave background. That's the faint afterglow of the Big Bang, our universal rest frame. Now, when astronomers plot the motions of thousands of galaxies across vast swaths of the universe, they find something truly unsettling. There's a distinct flow pattern, a cosmic current, with galaxies all converging on a particular patch of sky hidden behind the plane of our own Milky Way. This patch, this invisible cosmic whirlpool, has been dubbed the Great Attractor. It sits roughly 150 million light-years away, and the gravitational pull it exerts suggests it contains the equivalent mass of 10,000 Milky Way galaxies. That's an incomprehensible amount of stuff. Yet when we point every single telescope we have, from the most powerful optical instruments to infrared and X-ray observatories, at this region, we only see a fraction of the expected galaxies. Part of the problem is what we call the zone of avoidance. Our own Milky Way galaxy, with its dense dust and gas, blocks our view of about 20% of the sky. It's like trying to see across a smoky room. So initially, scientists thought, aha, The Great Attractor is just hidden behind our galaxy's dust, and it's full of normal galaxies we can't see. But even when we use infrared and X-ray bands, which can peer through some of that dust, the mass shortfall is real. There's just not enough visible matter to account for the gravitational pull. So something is definitely there. Something massive. Something opaque to starlight, even to infrared and X-rays. If this mass were ordinary matter, it should glow, at least in some wavelength. If it were dark matter, which doesn't interact with light, it should still bend light, creating gravitational lensing effects. While gravitational lensing surveys have found some dark matter in the region, it's only about half of the needed mass. The mystery deepens with the latest velocity maps from the Planck satellite. They show that the flow doesn't stop at the Great Attractor. Our local group of galaxies, including the Milky Way and Andromeda, along with thousands of others, is continuing to stream toward an even larger, more distant structure, the Shapley supercluster, located 1 billion light-years farther out. We're not just orbiting something, we're quite literally falling, being pulled by an immense, unseen gravitational force. The sensation is like standing in a river at night. You can't see the waterfall ahead, but the current is unmistakable, and it's carrying you along at a dizzying pace of 2 million kilometers per hour. This leaves us with two unsettling possibilities. Either our fundamental understanding of gravity starts to break down at these immense 100 million light-year scales, and there's some new unknown gravitational physics at play, or there's a previously unknown population of incredibly dim galaxies and warm gas, or some other exotic form of matter living behind the Milky Way's veil, completely hidden from our view. Either way, the local group, that's us, Andromeda, and 54 smaller galaxies, is on an undeniable collision course with whatever lurks there, and we cannot break. It's a humbling reminder that even our cosmic neighborhood holds secrets so vast they literally tug at our entire galaxy. If your brain is already doing backflips trying to process all this, then you absolutely need to hit that subscribe button and ring the notification bell. That way, you won't miss the next time we drop another mind-blowing cosmic mystery. And seriously, I want to know, which of these anomalies freaks you out the most? Drop a comment below, tell me your pick, and the top comment just might get pinned, and we'll dive even deeper into that specific enigma in a follow-up. Let's get this conversation going. The wow factor. Why these 5 matter together? So we've just taken a whirlwind tour through 5 of the universe's most stubborn enigmas. And what becomes clear, what truly forms the wow factor here, is that each case punches a different, gaping hole in our standard model of the cosmos. Think about it. Oumuamua, with its inexplicable acceleration and bizarre shape, utterly breaks our understanding of orbital mechanics and natural object formation. It challenges the very idea of what an interstellar visitor should be. Then we have Tabby Star, with its chaotic, massive dimming events, which completely shatters our expectations for stellar stability. Stars like it are supposed to be incredibly consistent, yet Tabby Star acts like someone's flicking a cosmic light switch. It forces us to reconsider the processes that govern even seemingly ordinary stars. Fast radio bursts, these millisecond screams from across the universe, break our understanding of compact objects and extreme energy phenomena. Even our best candidate, the magnetar, struggles to explain the sheer power and the precise periodicity of some of these bursts. They hint at physics far more energetic and exotic than we currently comprehend. And the odd radial circles, these perfect, gargantuan rings visible only in radio waves, fundamentally break our models of plasma physics and large-scale cosmic structures. They defy all known mechanisms for creating such symmetrical, empty shells on such immense scales. Finally, the Great Attractor, this invisible force pulling entire galaxy clusters, breaks our understanding of gravity itself at the largest scales. It challenges whether our current models of matter, both visible and dark, are complete, or if there's a fundamental flaw in how we perceive the universe's ultimate puppeteer. Put them all together and they form a compelling, almost unsettling pattern. The universe isn't just stranger than we imagine, it's stranger than we can imagine with the physics textbooks we currently own. Every new survey, every new telescope, whether it's the James Webb Space Telescope peering into the infrared, the Square Kilometer Array mapping the radio sky, or the Euclid mission charting dark matter, it seems to widen these cracks in our understanding, never seals them. And you know what? That's fantastic news. Those cracks, that's where new physics hides. That's where the next generation of scientific breakthroughs will emerge. These anomalies aren't just curiosities, they are signposts, pointing us toward a deeper, more profound understanding of reality. They are the universe's way of telling us, you haven't figured me out yet, not even close. Conclusion, closing CTA. So the next time someone tells you we've got the cosmos all figured out, that astronomy is just about mapping things we already understand, send them this list. 5 unbelievable anomalies, 0 consensus, and a whole lot of head scratching. If you want more deep dives into these kinds of cosmic puzzles, smash that like button, share this with that friend who still thinks astrology is the biggest mystery in space, and definitely tell me in the comments which of these anomalies deserves its very own full-length episode. Stay curious, stay skeptical, and always remember, the universe always has another surprise waiting just beyond the next dataset.